Right. So ever since I heard about climate tipping points about a month ago, I have been low-key obsessed with them.
Yeah, I mean, it's a pretty terrifying yet captivating idea. In a way, it's kind of remarkable that we actually don't hear about this more often.
Yeah, right. And what we're talking about when we say tipping points are these kinds of triggers scattered all around the world, things like the permafrost or the Amazon, which are like locked boxes of carbon emissions, which if opened could blow out the temperature by 4 or 5 degrees.
Right, so the Amazon is a big one, which makes sense given it absorbs something like 10% of the world's CO2 emissions. And most of the Amazon obviously is in Brazil. And for a long time, the government in Brazil had been putting the brakes on deforestation when Brazil elected its new president, Jair Bolsonaro.
Brazil's next president brings new questions about the fate of the Amazon rainforest. Bolsonaro, who's supported by the agribusiness lobby, has called for more dams and mining in the Amazon basin. He opposes increasing the number of protected areas and wants to reduce federal prosecutions for environmental crimes.
Deforestation has been a big problem in the Amazon rainforest. There was a time it was as high as 25,000 square kilometers every year.
In August 2018, 545 square kilometers of forest were cleared. That is 3 times more than the area deforested the previous August.
At the present rate, some experts predict there will be no Brazilian rainforest in 40 to 50 years' time.
Has continued deforestation in the Amazon and in the Atlantic forest drastically altered the climate.
What is at stake is so grave and so serious. If we don't act now, we are lost.
Okay, so that problem, logging the Amazon, is just one of a bunch of tipping points which climate scientists are talking about. And depending on who you ask, there are dozens of these. And once 1 or 2 are breached, then the rest could theoretically be triggered too.
Right, so to map out this fresh disaster for us, we called in Professor Will Steffen from the Climate Council.
A good analogy is a kayak or a canoe where you can tip it a little bit, and you can tip it a little bit more, and it comes back. It's stable. But if you tip it just beyond a critical point, it flips over into another condition or state. And there are actually many parts of the climate system that behave that way.
Okay, and so there are a number of tipping points, and if we breach them, then we have something called nonlinear climate change, which is kind of a dry name for a terrifying concept. Could you talk us through nonlinear climate change?
Yeah, what nonlinear climate change means is, again, like this tipping point concept, a certain amount of human emissions may generate a cascade of these tipping points. Think of a bunch of dominoes that you line up and you start tipping them, and then they tip each other down the row, and it sort of gets out of your control. Once you've got that going, you don't stop it. So the normal assumption about climate change is that the amount of warming we see is directly proportional to how much greenhouse gas, mainly CO2, we pour into the atmosphere. And that's what we call a linear relationship. The more you put in, the higher the temperature gets. But because of these feedbacks, we may get to a critical point where we put a little bit more of our own emissions in, and some of these tipping points start tipping. They generate that cascade. And even if we get emissions down to zero, the Earth would still go to a much hotter condition.
Okay, so that's terrifying in and of itself. But here's the strange thing. These scenarios aren't actually being counted in the current climate change models.
Right, and that's not so much because they're unlikely, but it's because they're just too much of an unknown.
They are hard to model mathematically. Some of them we still don't even have enough good understanding to model them. So if they can't be modeled well in a mathematical sense, they don't get into the climate models. So the climate models simply don't see them. And so they cannot simulate what those tipping elements, as we call them, might do to the climate system.
And so does that mean, when we get these somewhat apocalyptic forecasts for what might happen, the reality is actually possibly quite a bit worse?
Yeah, I think it is. And I think what we're trying to do here is present this as a risk analysis, that there is enough credible evidence for these tipping elements, even though we can't precisely mathematically model them. There is enough evidence that you're taking a big risk by pushing the Earth toward the upper of those Paris limits, 2 degrees, and certainly beyond. There's a very big risk beyond 2 degrees that you're going to start tipping those tipping elements.
Right, so these tipping points, and we'll get into exactly what they are in a second, are kind of like wild cards. They're really hard to factor in because we don't know exactly how they would play out, just that they would, in most cases, release enormous stores of carbon into the atmosphere.
Yeah, exactly, but they're not a total unknown because this has happened before, just a long time ago.
The last time the Earth had a really strong temperature increase was when we came out of the last ice age, which was about 20,000 years ago. So there was about an 8,000 year period from 20,000 years ago to 12,000 years ago where Earth's temperature rose about 4 degrees. And several of these tipping elements or tipping points were critical in increasing the temperature from the last ice age to the warmer Earth we enjoy today.
What happened? What were the tipping points that were reached back then?
Okay, there are two really critical ones. One is the loss of ice. So as the Earth warms a little bit, ice starts melting back, particularly in the northern hemisphere. So we have ice over Greenland, we have ice over the Arctic, we have ice coming down to the North Atlantic, big ice sheets over Western Europe and North America. As it warms a little bit, they retreat a little bit. But as they retreat, the darker ground underneath absorbs more sunlight. And that increases warming, which the glaciers retreat even more. At the same time, the solubility of carbon dioxide in the ocean, which is the biggest store, is dependent on the temperature. So as the ocean warms, CO2 is less soluble. So if you warm your Coca-Cola, CO2 will actually come out of it.
Right. I'd never even thought about ice having that function. It's like one of those reflective things you leave in your car and on your car window on a hot day.
It's exactly the same effect.
Right. So the last time a series of these tipping points were triggered, it ended the ice age.
Yeah. And we're staring down more of the same now.
Yeah, we analyzed 10 of them in the paper we just wrote.
That's a lot.
And they fall into two categories, those like the Amazon that emit more carbon to the atmosphere, and then the ones related to ice retreating, which uncovers darker land and water and absorbs more sunlight. And so the idea is you can think of this as a row of 10 dominoes. And the concern is, of course, if you start tipping a few of those, that raises the temperature even more, which activates some of the other tipping elements, which raises the temperature even more. And then it takes off, and you're going to go to a world that's 4 or 5 degrees hotter, even if we get humid emissions down.
Okay. And, you know, if we think about, like you say, these tipping points in two categories, there's the ice cover, and then all these kind of like locked boxes of carbon, right? Or locked boxes around the world. And so what are some of those? Would you mind, just at the risk of terrifying us further, would you mind just kind of listing off some of those? Because I've had a glance at the list and it's kind of it's all over the shop. Yeah,
look, there are 4 of them that are well-defined boxes and another 2 that are more distributed. The 4 that are sort of well-defined boxes are 2 of them that we've talked about. That's the Amazon forest, and the other one is the permafrost carbon. But there are 2 others. One is a forest, and scientists call it the boreal or the northern forest. And they're a belt of forests mainly across the top end of Russia and Scandinavia and Eurasia and across the top end of Canada and Alaska. Mm-hmm. And they're vulnerable to heating. What really gets them is a combination of insect infestations as you heat the Earth, and the northern high latitudes are warming at about double the global average. Another one then are under the ocean water in coastal zones. There is an enormous amount of carbon. They're called methane hydrates or clathrates. They're stored in the sediments under shallow ocean basins, and they have an enormous amount of carbon. They're thought to be more stable than the ones that we've been talking about, but still, if we go toward 3 or 4 degrees, there is a likelihood that we could destabilize those. There's a massive amount of carbon there. We actually have seen them destabilized in the distant past. About 56 million years ago, there was a massive outburst. We don't know what triggered it, of those methane hydrates, and it drove a spike in global temperature of about 4 or 5 degrees.
And these tipping points, if they're breached, could drive up the temperature by upwards of 4 or 5 degrees, at which point life on Earth starts to look very different.
And so that sort of scenario you're talking about there, 4, 5 degrees, what does human existence look like under that scenario?
Yeah, look, that's no, it's not good at all. Yeah. What we can say for certain is a lot of the tropics and subtropics are uninhabitable.
Because they're underwater?
No, because they're too hot.
Okay.
Remember that large mammals only evolved on the Earth when the Earth was cooling from much hotter conditions. So you'd very rapidly put the Earth back into much hotter conditions, and it would be extremely difficult for large mammals to live.
So it'd be like a extremely hot, humid belt around the middle of the world.
Yeah, and it would be extremely hot belt around the middle of the world. Large areas would be humid, but you'd also have some very deserty, dry conditions too, depending on how the circulation pans out in a much hotter world. So if you look at Australia, some people have done that, and there was a very nice paper done by Steve Sherwood at UNSW in Sydney, looking at, I think it was a 5-degree world, and he took the ultimate conditions for getting rid of heat by human body. In other words, you're standing out on a hilltop somewhere, you have no clothes on, the wind is blowing really hard, and it's raining hard. That's the maximum at which you can get rid of heat from your body. And even with that, in a 4 or 5 degree world, very large areas of Australia are uninhabitable. You would still die of heat stress.
Are we all sort of clustering at this point into sort of Manhattan level density in Tasmania? I mean, how does this work?
Well, no, what we're doing is we're probably clustering around the southeast in Tasmania, and we're going to have to spend large amounts of time probably inside with artificial environments that are cooler. Which people do in hot areas anyway. If you go to the southwest USA, for example.
Dubai or Qatar or something like that.
Or Dubai or Qatar, those places, yes, exactly. So you can do those calculations around the world, and a lot of the subtropics and tropics are basically uninhabitable. The scariest thing is most of the major food bowls disappear in terms of their ability to grow food. Northeast China, Central USA, Western Europe. So the real question is there any way we could possibly provide enough food for the current 7.5 billion people? Most people say no, which would mean a fairly rapid and drastic drop in human population. That would be a nasty world to live in.
Because of starvation on the way.
Yeah, because of starvation.
You know, I always think I want to do these stories, and then I do them, and then this happens.
You discover that ignorance is bliss.
Yeah. So which tipping point are we heading for first? Like, what's the first one we'll come across?
Okay. I think we've crossed one already, and that's the Arctic sea ice. That's another one of the frozen bits that uncover darker ocean water. We think it's now irreversible. Within a decade or two, that's going to be completely free of ice during the Northern Hemisphere summertime, which is going to accelerate the warming in the Northern Hemisphere and threaten some of those other tipping points.
And what happens after this tipping point? What's the next one?
Well, the question is, it may not be enough to start that pack of dominoes falling over, but we really got to worry about some of the other ones. Another one is Greenland, and their sea level rise is a huge issue because about 6 or 7 meters of sea level rise is stored in that ice, and the loss of that ice is accelerating.
And so we arrive at a familiar place.
Yes, a place we know well. Too well. And that place is the end of the world.
Yeah, but worth noting, we appear to have beaten Will Steffen to this very fatalistic conclusion.
You obviously haven't lost hope though yet, Will, or you're not standing on a hill naked in the rain yet.
Well, not yet, and my wife would be horrified if I told her I was going to do that. But anyway, look, I think what gives you hope is that just like these natural systems, human systems have tipping points, and we can change fast. We've been shown we can do that in the past. So hopefully within the next 5 years or so, we can cross the tipping point. Not that we solve the problem, but there is then a political decision across all parties that this is just too risky, and we're going to get our act together and get carbon out of our economies. That could happen. We're not there yet. And the hope is when we do, human societies can change pretty fast too.
Oh, there you go. So maybe we won't all die. Yes.